Good day, my friends out there. I still remain Dr. D. I. Ju, your regular chemistry lecturer and chemistry and social media. Our previous lecture was on the term stoichiometry, and I told you it expresses two important laws and facts. This is the law of constant composition or definite proportion and the law of conservation of mass. And stoichiometry per se, we said it is the quantitative aspects of a reaction that expresses the relationship between products and reactants in terms of quantity. So now we are a little bit going further to discuss a topic I titled mole ratios and mass relationship. Mole ratios and mass relationship. Now let us go by what I have in my notes yet. Now, the numerical coefficients of a balanced equation represents the number of moles of reactants and products. Numerical coefficient. Mathematically, if you, for example, you say 2a, for example, like I say 2a plus 3b. Now the coefficient of A is 2. The coefficient of B is 3. That's what it means. So when you say a coefficient, a numeral or a figure that comes before an alphabet, that is a coefficient. So the numerical coefficients of a balanced equation represent what? The number of moles of reactants and products. From these coefficients, we get the mole ratio of the reactants and the products in a reaction, for example, this. Now, this is tetrahydrogens of a 6-acid in aqueous, that is in solution. If it breaks down in ionization, you have hydrogen ion, that is a proton, and we have sulfate 6 anion. Right. Now, if you talk about the number of moles, that means what quantity of tetrahydrogen 6-acid in solution that decompose or break down to give hydrogen ion and sulfate 6 ion. Look at it now. This is hydrogen, that is H. There's no any other figure here. If there was any figure before this H, that would be the coefficient. Since there is nothing here before the H, it is representing 1. Here, the product, hydrogen, we have 2 before coming the H. So the mole is 2. Number of mole is 2. Here, there is nothing before the S. So the number of mole here is 1. So it means that if you want to interpret it now, 1 mole of tetrahydrogen of a 6-acid in solution break down or ionized into 2 moles of hydrogen ion and 1 mole of sulfate 6 anion. Now we can also talk about the mole ratio. The mole ratio is simply what? 1 is to 2 is to 1. That's the mole ratio. So in the ionization reaction above we are seeing here, 1 mole of tetrahydrogen of a 6-acid produces what? 2 moles of hydrogen ions and 1 mole of tetrahydrogen of a 6 ions in the solution. So therefore, the mole ratio in which reactants combine and products are formed gives the stoichiometry of the reaction. Can you see it now? The relationship is now that the mole ratio in which reactants are combining and the products are formed gives you what is called the stoichiometry of the reaction. That means that there is a specific quantity or a definite quantity of this substance that was in solution that produces a specific quantity of hydrogen ion and also a definite quantity of sulfate 6 anion. So the ratio is that 1 is to 2, then what? To 1. What we call the mole ratio. As we produce further we are gradually moving to some calculations, so be ready. So, like it, comment, and also share this video. Follow me on my page for more lectures. Thank you.